Hi, everybody. Good morning, good evening, good afternoon. It's good to be here with you all. Thank you so very much for hanging out. I know there's a lot of places that you could be, but it's really cool that you're here with us. I was watching that last talk, and I really like it, and quite the kind of the opposite vein of thought occurred to me at the end. Now, hear me out, okay? Just hear me out. What if there was an XML DSL for Gradle? Wouldn't that be? Wouldn't that solve some of the problems that people have with that, right? I think it'd be good. It's a declarative, fixed, non-programmable XML DSL. Okay, anyway, silliness aside, my name is Josh Long. It's so good to be here with you all today. I work on the Spring team. I'm a Spring developer advocate, a Kotlin Google developer expert, and a Java champion. And friends, I'm at your service. I'm on the YouTubes. How many of you are on YouTube? I mean, if you're watching this, statistically, you're probably watching it on YouTube. So I feel like this is not so out of left field. Just like and subscribe right there. Coffee Software, okay? A YouTube channel at Coffee Software. It's probably not the worst mistake you'll make this week. I mean, it's statistically you could do a lot worse, right? In your life than to subscribe there. What else? Code. We're gonna see a lot of code as always. People always ask me, where do I find the code? Well, it's here, friends. It's on GitHub.com. Josh Long, Bootiful-Spring-Boot-3. And should you have questions, comments, feedback, whatever, don't hesitate to find me. Well, first of all, at the end of our time here, I'll be answering questions should you like. But our time is limited. It's finite. So don't feel like the conversation has to end just because this particular session has ended. You can find me on email and josh@joshlong.com. And of course, I'm on Twitter where I tweet. I guess it's called X now, where I excrete. No, that doesn't sound right. Well, anyway, I'm there on the socials, so you can find me there. Okay, good stuff, my friends. Look, it's an amazing time to be a Java and a Spring developer. I'm very glad to have talked to Marco there, but I was halfway thinking I was going to talk to my other friend Mala, and I was going to ask her about what I should be reading to get certified on the latest and greatest in the Java ecosystem, because she's really good at all that kind of stuff. So oh well, there's never been a better time to be a Java and Spring developer, my friends. Truly, we live in an amazing moment in time, a unique inflection point in time, and I say that fully conscientious of where we stand. Right? If you look at the this website we built last year, spring1.io/history-of-spring, we built this little video game you can play with your keyboard, where you can see, starting from 20 years ago. I can never hit that first block. I don't know why. It requires you to be better than I am. Okay, anyway, so 2003, Rod Johnson, Jürgen Holler, Jan Karoff start the Spring Framework project. Spring Framework 1.0 was released in 2004. And by the way, this year, 2024, marks 20 years since the 1.0 GA release of Spring Framework, and it marks 10 years in April since the GA 1.0 release of the first version of Spring Boot. So when I say there's never been a better time, again, what I'm trying to say is, having been through most of these decades, I can tell you this is an amazing, unique moment in time, and I love this. Look at it. Spring Batch 3.0 released in 2014, 10 years ago, taking advantage of Spring Boot, Spring Integration 4.0, using integration flows without XML. So we went Java first back in 2014 with the release of Spring Boot. Spring Cloud 1.0 was released, providing tools for software devs. Spring Cloud Task is introduced, supporting the short-lived microservices. What else do we have here? Spring Cloud Data Flow. So by the way, I hope the subtlety is not lost in you. We're in the clouds, right? Look at that. Spring Cloud 1.0 is released. Spring Cloud Task, all that kind of stuff. Spring Cloud Data Flow. Now we're going back down. We're in water, maritime themes, right? Like water. So Spring Cloud Data Flow for Kubernetes. You got Spring Cloud Skipper. You got look at that. We got a cute little boat and the Spring Flag. Spring Cloud Gateway for Kubernetes. Get our weapon of choice there, and then we go into the castle. And we win. There's no shell game here. This is just a celebratory sort of moment for us, celebrating 20 years of innovation, right? And of course, urging people on to our tentpole conference called Spring One. So when I say that there's never been a better time to be a Java and Spring developer, I say that with that 20 years of perspective. It is just an amazing moment right now, a convergence of a number of things. So friends, in order to demonstrate that, as always, we're going to do what we always do. We're going to go to my second favorite place on the internet, start.spring.io. And we're going to build a new piece of software here. As always, I'm going to use Gradle, sure. We're going to build a new service using Spring Boot 3.2.3. That's the latest and the greatest. I'm going to name my service service. And the reason I'm going to name it service is because I'm amazing with names. I'm great with names. I get that from my father. He was also great with names. When I was a small boy, we had a small white dog, and my father named him White Dog. And then that dog was with us for like 10 years. Great family pet he was. And he disappeared after like 10 years. And I don't know what became of him. I was a small boy. I don't remember, but perhaps he got a job. Either way, another dog joined our family magically, looking for a home, tapping on our front door. And we took him in, and he was also a small white dog. And so my father named him Two. Now, amazing with names, amazing. You can see where I get that from. That said, my mom, she always tells me, she says, "You're very lucky that I named you." And that's probably true. So, okay. Anyway, we're gonna call it service. We're gonna use Java 21. Friends, you might have noticed there is no Java 8 here. Not even an option. It's not even an option. You cannot use Java 8 with Spring Boot 3.x. And Spring Boot 3.x is the current generation. Although that said, the open source support for 3.0 itself, which came out in November of 2022, is no longer there, right? So you can use, if you want to find out which open source support levels you have for different projects, visit the support tab. You go to the Spring IO projects page, look at the project, look at the overview to learn the details, get the documentation, and then check out the support timeline. So if you want to get open source support, these green ones are the ones that are available to you right now, the last year's worth of releases. If you want to pay commercial support, you can get, that's the yellow boxes there. And then beyond that, if you're on 2.6, there's just no support for you, none at all, right? You're completely out in the open. And so you really should be upgrading. That's the other lesson here, friends. And also, I was very pleased to hear that even Apache Maven is mandating a Java 17 baseline because, yeah, I mean, Java 17 is the absolute minimum, but I would say we should go a step further. I think you should absolutely be using Java 21. So you could use Java 17. It is the required and only baseline for Spring Boot 3.x, but don't use that. Don't use it. Use Java 21. Don't even bother with Java 17. If you haven't made the jump, don't even bother. Just go straight to 21. 21 is technically superior in every way to Java 8. It is faster, more robust, more syntax rich, more performant, more operations friendly. It's also morally superior in every way. It is morally superior. You will not like the look of sadness and chagrin in your children's eyes when they find out that you're using Java 8 in production. Don't do this. Be the change that you want to see in the world. Do the right thing. Use at least Java 17, but ideally Java 21. I'll go a step further. I would say that to use Java 17 when there is Java 21 on offer is basically borderline software malpractice. You're leaving real money on the table for the equally same level of ambition required to upgrade to either, and you chose Java 17 when there's Java 21. You have screwed up royally. There's real money that you're just throwing away by not using Java 21. So we'll talk about that today. Okay, we're going to add the GraalVM-native image support. We're going to add the web support. We're going to add the Spring Data JDBC support and Postgres. Here's this as well. We're going to add the DevTools support, and we're going to add the Docker Compose support. So I've got GraalVM, I've got web, I've got Postgres, Spring Data JDBC, DevTools, and Docker Compose. Let's open this up in our IDE, UAO service.zip. All right, loading. Oh, you know what I forgot to do, friends? I forgot to load one more thing. Haha, I forgot to add one more thing to the build. I'm going to add OpenAI support. Okay, now we hit generate and open that up in our IDE. Okay, good old IDE. I love this IDE. They should have a conference where people talk about how much they love their IDE. Wait, is that this? Yeah. Well, anyway, as you can tell, I'm a big fan. I appreciating where I am and trying to read the room a little bit. I probably should have just gone here, file new project, and then chosen the Spring initializer right there. Right. That actually uses behind the scenes. It uses the same web service as start.spring.io. It's actually the exact same result, same flow, same everything. It's just built into the IDE, and you don't have to do what I did with the downloading of the zip and then the unzipping and the opening it with your IDE. It just works, right? So it's actually a lot faster. But I'm not that smart. I didn't do that. You should do better next time, okay? Don't do as I did, do as I say. All right, friends. So we've got our public static void main, our new application. This is a data-centric application. And so to that end, I'm going to start by defining our data model, right? Integer ID, string name. Look at that. I'm using a Java record. I love Java records. I love them so much. This is so nice. Look how convenient and concise that is. Now, friends, Java records are just part of the story here. Obviously, this is just one of many things that have landed in Java 17 and later, but that if you take them all together, if you take all the sum of these different features together, they culminate in Java 21, the release that we're using, as a new set of features supporting something that they're calling data-oriented programming, okay? And the core conceit, if you were to talk to Brian Getz, Java language architect, Brian Getz, he'll tell you that the reason that they have all these new features, which include sealed types, records, pattern matching, and of course, smart switch expressions, right? If you look at all these features, these 4 features taken together support this new paradigm called data-oriented programming. And if you ask them why, they will say, well, that Java has historically, traditionally, dominated the world of the monolith, right? If you're building large services and systems and scale and so on in a single code base, Java's a good compiler and its access control and its privacy protections and so on make it easy to build a scalable, modular, monolithic application. And indeed, by the way, friends, we have a project called Spring Modulith, which is just a set of architectural conventions on top of Spring Boot to help you build out a scalable, modular, monolithic code base. So it's definitely a good idea if you want to do that. And Java has dominated that ecosystem for so many years because it makes building such a code base very easy technically, right? That said, increasingly, even our larger monolithic services are being more readily broken down into smaller things. Maybe not a microservice, right? I like microservices, but certainly smaller because you have just more moving parts, more services with which to integrate these days. For example, authentication and messaging and all that. So we have these more smaller, fine-grained services these days, and increasingly the vector by which we communicate change in the system is no longer in terms of these abstract subclasses, these specializations of abstract types with overridden methods. Instead, we communicate that change through messages, usually ad hoc messages being conducted over the network, via RabbitMQ or REST or whatever, right? These kinds of small ad hoc messages increasingly are coming from JSON, they're coming from gRPC, they're coming from protobufs. They're not deep hierarchies of abstractions. They're just little carriers for little vessels for data. And so our language has to support this new paradigm of communicating change in a system, of designing that same change in the system by accepting and working with new data types. So let's take an example, friends. Let's say I work in a highly regulated industry and I've got a loan. Now, loans are in a highly regulated industry, very, very heavily regulated, right? They're a financial instrument. There's a lot of wiggle room for malfeasance. So we want to make sure that when we implement loan, that we have well understood code paths through which that loan type can flow in our system. So let's create a class for a secured loan, okay? Implements loan. And we want to have another class here called a unsecured loan that implements loan. Now, we don't want just anybody, any old someone to come along and create an anonymous inner class version of this loan, right? We want to make sure that we understand exactly where in the system there are implementations, and we want to make sure that our system is handling both code paths and applying all the validation required, therefore, as cleanly as possible. So I'm going to use a new feature here called sealed types, and that allows me to foreclose upon the possibility that there are other implementations in the system of this interface about which we don't know, right? I'm going to say that we only have these explicitly allowed things. Now, the compiler's still unhappy with us. We need to make this final, or we need to reseal. We need to say this is seal and to explicitly close off any further subclassing, okay? So I've got now very, very good idea of where I have implementations of that. Let's say I wanted to display a message for that loan, okay? Well, I could inject, I could pass that as a parameter there, and maybe I create a message, right, like this, and I could do something like this. I could say if loan, instance of secured loan, var SL equals secured loan, and then I could create the message, and I could say, oh, Nice. You got a secured loan. Good job. Good credit score. Right? Good stuff. Very, very affirmative message. But then, of course, in typical bank fashion, we might be like brazenly hostile to people who have to get an unsecured loan, right? So unsecured loan, here we go, loan, and then we'll say message equals, that, and let's imagine that this is an interest rate, okay? We need to get some interest. So what I'm going to do, friends, is I'm going to make this unsecured loan a record, okay? Our old friend record, and the contract with a record is, first of all, that it's explicitly final, but that it's a carrier for state, and that carrier is just a named carrier. It's effectively a tuple. Java doesn't have tuples as such, but we do have records. Java has tuples that have names. Java is a nominal language. Things have names in Java. So tuples in Java are just called records, and they have a name attached to them. And the contract here with a record is very, very convenient. It says that the identity of the unsecured loan is equal to the identity of the components that we're describing here in the constructor, right? So like if I just added these other fields, then I could say that the identity of an unsecured loan, the things I would need to recreate the unsecured loan, since there can be no computed state, is exactly equal to these three different component variables. If I specify those three different variables, I get back an unsecured loan. Easy peasy, okay? So the identity, the equals function, the toString, the hash code, are all functions of those component variables. And if we're willing to agree that contract, then the language can do us some really nice things. It can create a constructor for us. It can assign storage for those variables. It can create getter methods for us. It can create the aforementioned equals hash code toString methods. So it gets us a lot just by using records where appropriate. And so here I've got an unsecured loan. The identity is equal to the interest. And now I can dereference that interest, okay? And so this is, I guess this is okay, but let's clean this up if we can a little bit. First of all, we could use pattern matching, right? So pattern matching is the idea that if I extract out a pattern, loan is instance of the secured loan, then as long as the compiler knows that it is definitively castable, right, I can actually assign the result of that extraction to a pattern match, right, a variable. And so I'm saying here, hey, if this is an instance of secured loan, then do this, okay? What about down here, okay? USL, great, not bad, look at that, much nicer. But things can actually get a little better, right? I actually don't need the container of the record. I don't need that. I need the component. I want the interest. That's all I'm doing is I'm dereferencing the interest. Well, if that's all I want, I can actually dereference it. I can extract it by using more pattern matching here. And so in the scope of this test, this component variable is now available as a float. And I used var, but the compiler knows it's a float because that's what it is down here. And so I can assign it. Okay, that's better. But still, what happens if I comment that out? Nothing happens. That's the problem, right? This is very dangerous because I'm not handling one of the code paths here, right? I might be failing to comply with some local regulation, for example. So it's very important to have the compiler check your work as much as possible. So let's rewrite this code to both simultaneously be better, more strict, and more elegant and concise by using smart switch expressions. Here, I'm going to switch on the loan itself. I'll say case unsecured loan, okay? And I'll just return this. And I can use the same kind of pattern matching there, okay? So there we go. I'm doing a case, okay? Now, what about the other one here? I can say case secured loan, okay? And I can return that as well. Nice, okay? Very good. So now I get rid of all that. And really, I don't need the intermediate variable anymore, do I? I can just do that as well. And so I get the same benefits as before, right? I get the pattern matching. I get the case. It's actually cleaner. I don't have to have that messy intermediate variable which I assign to as a side effect of each of the branches anymore. And if what happens if I comment at one of the branches? The compiler says, "Hey, what are you doing? You forgot to cover all the possible input values. It's not exhaustive." So this is the compiler watching our backs for us, right? Now we've got cleaner code, better code, the IDE ably guiding us at every step. So this is all these different features. This is not the thrust of our talk today, friends. I'm not really trying to, it's not a Java 21 talk, but I do want you to understand Java 21 is huge. This is one of the biggest, nicest changes to the language. All these things taken together get you to the point where you can write code like that, and which is actually the better code that's more testable, that's more guaranteed to work the way you expect it. So, okay, let's move that out of the code base. We don't care about that for now. I just wanted you to see that when I use a record here, you shouldn't sleep on records because they're part of an amazing ensemble of features, okay? What else are we going to do? We're going to create a repository to extend the CRUD repository. This is a interface in Spring Data, and basically it's a repository that provides methods like find all, save, delete, etc. And it's going to let us work with entities of type customer. This assumes, of course, that we have an HTTP endpoint by which to access the data. So I'll create an HTTP controller. Okay, private final customer repository, inject that there. Get mapping customers, collection customer, voila. Okay, return this repository at find all. Very good. So we'll add this at controller at response body. Okay, very good. So now we have our simple HTTP controller, but it's going to talk to a database. What database, right? Well, remember, I have on my build here, I have the Docker Compose support, right? I chose that. And because of that, the Spring Initialize was nice enough to generate this Docker Compose file for me. I'm going to make it a little bit easier, I'm going to make this export. I'm going to export the port so I can use it on my local machine. But basically, when we start the application up, it's going to automatically start the Docker Compose file for us, which is good. We're also going to use DevTools. DevTools are a way to allow our application to go faster. And the way it works, the core conceit behind that is that Java, while being many things, is not particularly fast to start up. And so if we just keep the JVM running, keep it warm, and then whenever you compile your code in your IDE, you use Command Shift F9 here, right? If you recompile the code, or if you do a save in those other IDEs, right, like a whatever, there are no other IDs surely, but if you do a save and those other things, or recompile in this, then the result will be that you get a new class file on the disk, and then the dev tools will see that new class file. It'll create a brand new class loader, and then create a brand new Spring application context with those classes in that class loader. It'll throw away the old class loader and the Spring application context, and then load that. So the effect is that you get this really quick lightning speed turnaround time when you make changes, rather than having to wait for the full JVM restart, because Spring is really quick to start up, but the JVM is not. Spring is really quick to start up, that is, unless you do what we just talked about, which is run a Docker Compose file on every single restart. We don't want to wait for Docker Compose to start up everything each time we start up the application. Imagine you're making changes to CSS or something, and then you get new Postgres each time, right? That's not how Postgres is supposed to work. So what we're going to do is we're going to put a property here, Docker Compose start only. So it'll start the container if it doesn't exist, but it'll let it run if it does exist. Okay, and then we're going to start it up. So we have the application. We need actual data in the database. So let's go back here to source main resources. I'm going to create a new file here called schema.sql. Create table. If not exists customer ID serial primary key name text not null. Okay, there's this, and then I'll create a new file here called data.sql, and I'll say delete from customer, insert into customer name, and I'm going to just put some people on the Spring team here. Hi, my name is Josh. I'm certainly there. What about Jürgen, the lead, the amazing Jürgen Holler? We've got Madura, we've got Olga, we've got Violetta, we've got Dr. Sire, we've got Yushin, we've got Stefan, we've got Spencer. There we go. There's 9 names. One more won't hurt. Who should I put? Oleg. Sure. There we go. So now we have 10 names. Good stuff. So I'm gonna restart the application. I want Spring Boot to automatically run that SQL files, those SQL files, to initialize the application database when we restart. So I'm gonna have this file property called Spring SQL init mode always. Okay, so it'll automatically run that on every single restart. Okay, so the first time, remember, it's gonna run Docker Compose and everything else for us, and this might take a little while, right? It's very slow because we have to wait for the Docker. It's literally talking to the Docker daemon behind the scenes. But then hopefully thereafter we won't need to go. We won't need to work so hard. Okay, so let's see. Is it struggling for some reason? This is actually longer than usual. Oh, there you go. Okay. So there we go. There's the output. Docker daemon responded. So that was a very long time. I don't know why. That's the Docker daemon. Restarting it again. Okay, there you go. So that was 1.3 seconds. Like I said, super, super slow. I restarted it again. I did a full restart there. This is what I normally see. If the Docker image is local on my machine, then it takes about 1.37 seconds, which is very, very, very slow. I don't want to wait that kind of time. So I'm going to use the dev tools here henceforth, right? So let's see. We've got this endpoint localhost 8080/customers. It's worked. Of course it worked. It was a demo. It was always going to work. And so let's try hello customers. Voila. Command Shift F9. Do the recompile. So there you go. You can see here it's 0.43 seconds, right? So I go back here, refresh, and now I get hello customers, right? So Command Shift F9, and I can make the change faster than I can even see it, right? Reflect it, right? Okay, good. So now I'm moving quickly. I've got that git clone run lifestyle, thanks to Docker Compose support and the easy automatic connectivity that we've got. You notice that I didn't have to specify Spring data source URL, password, etc., because Spring Boot knows that I'm in development mode. I've got this Docker Compose file. It knows, first of all, to start up the Docker instance for me, the Docker images, but then also it creates a connection to, it creates a data source pointing to that newly minted data source that we've just got there. So this is great. We're actually making really good progress here. Okay, so we've got our customers endpoint. We've got our git clone run lifestyle, moving quickly with dev tools. Life is good. We got Java 21, really concise syntax. I think we're doing really good. That said, this is all pretty stock standard stuff, isn't it? This is the kind of stuff you could have done years ago, right? This is not particularly new. I talked about 20 years of Spring. Well, certainly you've been able to create web apps talking to databases for that entire 20 years. It might have been more verbose, certainly, right? We didn't have Spring Data repositories up until about 2010. So this is a far sight more concise and more elegant than the alternative. But that said, it's still pretty stock standard stuff, right? It's a web app babysitting a database, and this is great. It's just it's a leap forward, but it's still pretty stock standard stuff. There are, of course, always new frontiers, and these days, as often as not, I hear about artificial intelligence, AI, because the search for regular intelligence wasn't hard enough. And the idea here is that there's this Cambrian explosion, this burgeoning ecosystem, rooted, by the by, right here in my beautiful city of San Francisco, which is not putting on the best show that it could tonight, but it usually is, or this morning rather, but it usually is quite beautiful. And we are the #1 AI capital of the world right now, right? It is like this. The #2 is New York City, and they don't even have, they have less than half the number of new jobs every day than San Francisco does, right? So it's not even close. It's just an amazing moment in time, a very unique moment in time. You hear about it in the billboard. You see it in the billboards. You see it on the freeway. There's ads for AI, and jobs and interesting stuff around that. So it's just a very interesting place to be. And of course, to that end, we have a project called Spring AI. And you saw when I started the build and the initializer, I added OpenAI, right? So in the Spring project, AI is a huge thing. Remember, most people don't need to build new LLMs, right? They're not going to be using Python and C to do that. What they're going to do is they're going to integrate with an LLM, and that's where things get interesting. You see, Spring is second to none when it comes to integration with all sorts of infrastructure and services and so on. And so we have the Spring AI, OpenAI, Spring Boot starter here, but Spring AI is just one of literally dozens of different things you could concern yourself here. Start.spring.io, choose AI, you'll see Azure, Stability, Amazon Bedrock, OpenAI, Vertex AI from Google, Chroma Vector, Milvus, Neo4j Vector Store, Olama PG Vector Store, Pinecone, Postgres Machine Learning, right? Redis Search and Query Vector Database, Transformers, Onyx Embeddings, Weaviate, etc. So all of this stuff is on the Spring Initializer. It's all part of this new project. And remember, in the same way that most of us just need to integrate with LLMs, there is a whole data lifecycle in the same way that integrating with a SQL database can involve all sorts of steps before you actually get to the SQL database. Most of us don't need to write our own LLMs in the same way that most of us don't need to write our own SQL databases. And so there's a whole lifecycle, like I said. Think about it, right? Most of these different LLMs, these chat APIs, these image generation APIs, etc., they support a token context window size. You can send only so much data per request. And so the goal, and the other thing you have to keep in mind is that these LLMs have an expiration date, so to speak. They have an expiry date, after which point their data is stale, right? So if you ask them about current events that happened yesterday, good chance it doesn't know what you're talking about, right? After a certain point, it doesn't know what the latest and greatest in the world is. And so you have to give it up-to-date information. And by the way, even if it did understand world events, it's not going to know about your database, right? It's not going to know the context associated with your users and your data model. So you need to inform the LLM of what's happening and give it a way to ask questions. And the way you do that is by stuffing the prompt. When we say stuffing the prompt, we mean sending information in the prompt so as to give the context to the LLM so that it can then answer questions with up-to-date knowledge. And so, for example, imagine you have a bank, right? A website where you've got a little IVR, a little agent that sits there on the side of the window that's answering questions about the user's bank account. Well, you need to tell the LLM, hey, this is user Josh. He has this much money in his account. He owes this much. He owes blah, blah, blah. And then you pass along the question that the user sent. With that backdrop, please answer this question, right? And the LLM can do that now. It can know, hey, this person has this much information. This ability to craft a prompt and do so with context is prompt engineering. It's a whole school of engineering. And you always thought that those English classes they made you take in your IT vocational school weren't going to serve you. No, or whatever language, learning a language right now, human languages is a really good idea. But anyway, so the question then is, okay, well, I want to send as much data as possible, but obviously I can only send so many tokens. We just talked about that. There's a token window size. So you want to make it so that you have as much data as you need, but you can summarize it and digest it down to a form that you can then fit into that context. So one way to do that is by making the data searchable. And you can do this with vector databases, right? This is a new kind of database. It's algorithmic. It's actually just we actually have an in-memory version in Spring AI because it is all just CP. It's just all algorithms and so on. You can write the math if you are familiar with it. You can write down the code pretty easily. So we have one, but there's a number of other ones out there. There's Redis and Neo4j and Weaviate and so on. And then even there, friends, how do you get the data into that vector store in the first place? You have to ingest it. So there's a whole pipeline of ingesting, storing, querying, and then integrating with the LLMs that has to happen. And that's all in purview for Spring AI. So we don't have time to cover all of that, surely. But we can use Spring's support for OpenAI. I have that in the class path here. And so let's just build a simple service. Let's do that here. We'll say @controller, @response body, story controller, okay? And I'm going to inject the chat client here. I'm going to call it the singularity. Here we go. Now we're going to ask our endpoint here to tell us a little story, okay? I'm just going to say create a story, and we'll do this here, story, and there we are. Okay, so now let's actually craft our prompt, okay? Multi-line strings, yet another lovely feature in modern versions of Java. And then given the prompt, we'll get a reply from the LLM, this.singularity.call, passing in the prompt, okay? And then that response is we're going to put here. It's a string, okay? Very good. So let's write our prompt, and it's this is a lot of the fun. So, dear singularity, it's important to be polite. They'll remember this when they take over. So be polite. Dear singularity, please write a story about the amazing Java and Spring Boot users wielding the next level, second to none awesomeness of the JetBrains IntelliJ IDE. And please do so in the style of famed children's author, Dr. Seuss. Now, Dr. Seuss is one of my other favorite doctors, along with Doctor Who, Dr. Strange, Dr. Subramaniam, Dr. DeVolder, Dr. Pollock, and Dr. Sire, and Dr. Nepas. My IDE is trying to help me out here. Okay, it's very, very good. There you go. Welding. No, wielding. Is that not a word? I feel like that's a word. Is it wielding? Sure. Okay, good. There we go. Okay, cordially, Josh. Okay, so there's our prompt. We're going to send that to the AI, the LLM, via this abstraction called the chat client, of which there are, like I say, countless implementations. We'll get a response, and we're going to then register that here in the map, and that'll be rendered as JSON. So let's do Command Shift F9, force the recompile there, 0.43 seconds. Good. Localhost 8080/story. And now we wait. Here we go. We got a response. Okay, so in a land where code runs wild and free, there live Java and Spring Boot, a dynamic duo, you see. They work their magic with IntelliJ idea in hand, creating software that was simply grand. With JetBrains on their side, they were a force to behold. Their creations were cutting edge, daring and bold. They coded with speed, precision, and flair. Their projects were flawless, beyond compare. The users marveled at the skill and finesse as they navigated IntelliJ with such ease. They debugged and tested with a flick of a wrist. Their creations were bug-free, never missed. Hey, it's pretty good. The Java and Spring Boot users were a sight to see, harnessing the power of IntelliJ with glee. Exactly. So anyway, you get the point. That's amazing. You get the point. We can talk to the freaking singularity now, and it was easy. And by the by, you might be wondering how that worked, because you didn't see me configure anything, right? Well, of course, you need to specify a key. And friends, what you need to understand is that before we got on screen here, off screen, I exported an environment variable like this in my shell, and I specified my API key. So forgive me for not leaking my credential, but just trust that that's been done, okay? You have to do the same thing, otherwise this won't work for you at home. Okay, so now we've got the freaking singularity. We've got git clone run, a nice, consistent, elegant language, making real progress here very quickly all the time. That said, you know what wasn't quick? The response from the LLM. Now, don't get me wrong. I'm not I get that relative to me, for example, that was super quick. I couldn't write that poem that quickly. No way. But from the perspective of our system, from our software, yeah, that wasn't super quick, was it? Think about what happened, right? We called /story, and then that ultimately invoked the dispatcher servlet, which in turn knew to look for our controllers, which in turn invoked our method, which in turn in which we invoked the LLM, which in turn opened up somewhere down in the bowels of the code a network socket calling to the api.openai.com or whatever it is, and giving us a socket back. We then, from that socket, got an input stream, a Java IO input stream, and then we called input stream.read, right? We've all written this kind of code before, where you're reading data from an input stream, right? Something like this, right? Let's just say void read whatever throws exception var in new file input stream foo.txt, and you say try this and then that, and you say var next equals -1 while read next equals is.read, okay, like that, does not equal -1. Then we say do something with it, right? So whatever, system out dot next, right? So we're just reading the data from the byte stream as quickly as possible while it's not -1, and then we're doing something with it. We're accumulating it, we're writing out to another output stream, whatever. And that works, but what happens here? What happens if we do input stream.read and we're calling this is a file input stream, but imagine network IO, right? Like imagine we're making a call to another host and port. We're asking for the next byte. That service might go down. The server might have an issue. It's probably written in PHP. You can't trust PHP. It'll leave you in a minute. And imagine that thing doesn't work. Or imagine, in this case, we called the OpenAI endpoint, and it worked. It just took some time. I don't begrudge it that time, but it did take some time. What's happening in our system when we call input stream.read? We're asking it on line 50 to read the next byte, and we don't get to line 51 ever until input stream.read returns. So hopefully it does return, right? If that service times out, then you got a real problem. Hopefully you've specified a timeout. But what if it doesn't return? What if it just sits there forever in perpetuity? Well, this isn't such a big deal here, but what we just discussed was actually happening inside of a Java thread. We're calling input stream.read in a Java thread, one of tens or hundreds or maybe even thousands of threads in our system, each of which is handling one brand new HTTP request. So for each HTTP request, we have threaded code, and then we have this bit where we're doing I/O behind the scenes, and that I/O again is a landmine of problems, right? Imagine any one of those should fail. Now we're stuck waiting for a byte that will never arrive, and we're not able to proceed to the next line. We say that that operation, input stream.read, is blocking. It's blocking the thread, and that thread is unusable in the meantime. Now, there are ways to get around this. Obviously, you can rewrite your code to use non-blocking I/O, NIO. This is hemorrhoid-inducing on the best days, and worse on the worst days, right? It's a lot worse. So nobody wants to do that. And even if you did want to do that, most of us don't want to think in terms of I/O anyway. Like, you don't really see Java I/O happening in our code base as such, but you have to know behind the scenes, somewhere in the code base, that's actually happening. And so we want to make sure that we're not wasting time, and we could move up the abstraction stack and use it. Instead of using non-blocking I/O directly, we could use something like a reactive programming. This is a paradigm. It's a different way of thinking about how you write your code. I love reactive programming. I wrote a whole book called Reactive Spring. I'm a big fan. That said, yeah, maybe it's not for you. Maybe you're not. Maybe you just haven't gotten the functional gist of it yet, and that's okay. I mean, Java is not a functional, or at least hasn't historically been a functional language, so it's not natural to expect people to have that. Maybe you don't want to, and even if you understood it, maybe you don't want to have to rewrite every bit of code you've ever written to be able to take advantage of that. But what if we could have our non-blocking cake and eat it too, right? And we can now with Java 21. There's a new mechanism in Java 21 called virtual threads. And the way that that works is that the runtime detects any instances where you're doing a blocking thing. And I showed you input stream.read, but there are also output stream.write. There's thread.sleep. There's a few well-understood, well-known cases in the runtime where you might get stuck on a line and be unable to proceed to the next line. But the runtime will detect that now. It'll detect the blocking thing. It'll move that code into RAM, off of the thread. It'll put back the real thread back into the thread pool and allow something else in the system to use it, all without you having to write a single callback. So to demonstrate this, I'm going to steal an example, just blatantly plagiarize an example here from Oracle Java developer advocate Jose Pomac, who's amazing. And I appreciate him for these amazing examples. So let's go here. For var I is 0, I is less than 1,000, I++, threads.add. And what are we going to do? We're going to create 1,000 threads. I'm going to create 1,000 platform threads. So these are the kinds of threads that we've been creating for the last 28 plus odd years. Okay. And we'll come back to what we're going to do in that thread. But what you have to understand is we're creating 1,000 threads here. Okay. And we're adding them. And then once I've done that, I'm going to go through each thread and I'll say t.start, start it. And then I'll do the same thing. I'll wait for each of them to finish. Okay. So three different loops through the, first of all, we're creating the threads. Second of all, we're starting all of them. Then we're waiting for all of them to finish. And then finally, we're going to print out what we have seen the thread names to be. So in these unstarted threads, right? Remember, they're unstarted. They're platform threads. We're going to take note of the current thread's name if we are in the first of the 1,000 threads. So I'll create a variable here. Let's do that. Okay, and put this up here. So if we're in the first of the 1,000 threads, we're going to take note of the current thread name. And we're going to do that by putting them in a set, right? Now remember, sets are deduping, right? If you put the same element in the set 5 times, it'll only appear once, right? You don't get multiple cardinality values in there. So if first, then names dot add thread dot current thread dot toString, okay? And then we're going to sleep. We're going to block for, let's say, thread.sleep. We're going to block for, like, let's say 100 milliseconds, okay? Voila, catch, throwable T. All right, good. So we're going to do this now. This is one time. So I'm going to take note of the current thread name, and then I'm going to sleep for 100 milliseconds. And we'll do that again, second time. And we're going to do it again, third time. And again, fourth times, okay? So we're sleeping for a total of 400 milliseconds for every single thread. But on the first of those 1,000 threads, we're going to write down the name of the thread in a set which will dedupe it. So if it appears more than once, it'll be deduped. But if there's unique elements, then we'll see them reflected. Okay, so let's run this. And now that I've taken note of the current thread names, down here, I'm gonna write out the names, okay, to string. So Command Shift F9, recompile. Here we go. Where we go? There we go. Look at that. So we have an array with one thread in it. Okay, that means the physics of the program hold, right? It's as we expected, because we started executing here on line 42, at which point we were on thread number 266. And then we went down here, and guess what? We're still on thread 266. That's exactly what you would have expected from 28 plus odd years of Java programming, okay? But the problem is, that means that we're stuck on this thread. The runtime hasn't given this thread back to the runtime, right? To the thread pool. And that means that we're sitting here waiting for that 100 milliseconds. I don't want to wait 100 milliseconds. That's a long time during which something else in the system could be using this thread, right? But we're bogarting it. We're monopolizing it here, greedily doing thread.sleep and then keeping the thread out of availability for that whole time. We're wasting 400 milliseconds. It's 400 milliseconds of idle time, and yet we have no threads to show for it, right? So what if we could have the code rewritten in such a way that as soon as we start the blocking thing, we get moved off of the thread. There's an egg timer that gets set, that gets run in the background, and as soon as that egg timer goes off, we get put back on another thread, able to continue. Because I don't really care, right? I'm not using the thread. Why do I care what thread I'm waiting on, right? So we can do that now by changing the kind of thread we're using from platform to virtual. Okay, so Command Shift F9. By the way, that's all I did. Thread.ofVirtual, right? And you can see now, oh, look at that. We ran on the same logical thread 1300, 1300, 1300, 1300 for the entire run of the program. But the actual operating system thread changed. That's because we ran the program here, slept for 100 milliseconds, and then the thread that we started on is no longer available, so it moved us to a different one. That's okay. We don't care. Logically, it's still the same one. If you used a thread local, that would still work, right? Everything is still there. It's just that behind the scenes, the actual operating system thread changed out from underneath us because we're not wasting time on that thread. It's moving us off the thread as soon as we're done waiting. This gives you unparalleled scalability. It's like the scalability. It's almost as good as the scalability you get with reactive without any rewriting or refactoring of code. This is a miracle. This is an amazing result here, friends. This is why when I say to sleep on Java 21 is basically software malpractice, because this will allow you to scale down. I can't give you exact numbers, obviously. Benchmark it for yourself, but I'll bet you can scale down instances of your service in the load balancer because now you'll be able to handle that much more scale for free. Now, this is obviously low level. I'm creating a low level thread here using the factory method. And higher level code, you'd probably use executors, right? New virtual thread per task executor. This is all very low level, right? This is a new executor, by the way. It's not a thread pool, but it creates a brand new thread each time. So this is a new executor.
Just a tiny second. I hate to interrupt. I just wanted to know, we have roughly 9 minutes left. There's just a couple of questions, so feel free to finish that amazing section. I just wanted to let you know.
Oh, very good. We'll get to them as soon as we can. All right, so let's finish this. Let's find our way home. So we've got a virtual thread pool. Now this is also very low level. I'm going to, I don't want to write low-level executive service code. If you're using Spring Boot 3.2, you don't need to either. You can say Spring Threads virtual enabled equals true, and then that will do this for you. We'll plug in a non-blocking, virtual thread pool in all the places that make sense now automatically. So that call to the AI where we're sitting there on a thread waiting in Spring MVC, who cares now? We don't care. It doesn't matter if it takes a second. We're not losing time on that thread. That system is now able to handle the scale, and it's guilt-free. And this might change the way you write software, by the way. Like, what would you do if you knew that it didn't really cost anything to create a blocking, long-lived operation on the front-end web thread pool, right? Like we do so much work to move things off of the front-end thread pool and move to a back-office process so that we can scale that up horizontally. But now, like, why not? Why can't I resize the image on the web front-end server? Why can't I send the email there, right? Why can't I do the batch process or whatever? I mean, you probably could now, right? It's try it yourself, see what happens. Imagine it's not just that you can run this one instance with fewer instances, this one service with fewer instances. It's that maybe there's a whole bunch of extra services that used to logically make sense as separate services because you could scale them out, that maybe you don't need to worry about anymore. Maybe it's just fine to stuff them back into a larger code base. Thank you, virtual threads. Okay, so we've got virtual threads. We've got the freaking singularity. We've got git clone run, Docker compose, moving quickly, nice syntax, time to go to production. Friends, here we've got a few things we need to care about. How do we containerize this? Well, friends, I'm not even going to spend time on this. That's an easy one. Use build packs. Friends, don't let friends write Docker files. Use build packs. This will give you a container that you can then deploy to your application. If you're using to your container runtime. If you're using Spring Boot, obviously Gradle build boot image. That'll do the same thing. Okay, that's part one. Part two is, how do we package this application so as to be as efficient and fast as possible? And friends, here, I think it's worth taking a moment to really stress that Java is already super fast and super efficient. And this is, I think, well epitomized by this blog from 2018, before the COVID pandemic, or BC. And this blog asks the question, which programming languages use the least electricity? And it looks at a number of different languages, and it says, okay, C is clearly the most efficient language for machines, not for people, definitely not for people. For machines, it's the most efficient language. Rust, doing quite well, zero cost abstractions, good job, well done. C++, disgusting. Moving on, Ada, but who cares? And then Java. And then Java is 1.98, okay, friends? What that means is it's almost 2.0. So round up, simple math, 2.0, okay? It's twice as inefficient as C, or C, put another way, is twice as efficient as Java. Good stuff. Moving on, you got Lisp, you got C#, you got Go, Away, you got JavaScript and TypeScript. I don't understand this. How is one almost 4 or 5 times worse than the other one? I thought TypeScript compiled down to JavaScript. This is a problem. Friends, look, if like me, you find JavaScript to be a nightmare language and you want some types, even if it's just a serenity blanket that you clutch at night to feel like your code has been compiled, even though it's just a lie, it's barely a linter. But if you want that serenity blanket of TypeScript, then you and I are in the same boat, and our boat is leaking. Okay, this is a problem here. Anyway, we have these disgusting languages. Disgusting. The less said about which the better. Moving on, and then friends, we got JRuby and Ruby. Now JRuby is Ruby written in Java, and Ruby is Ruby written in C. And you can see that JRuby, by dint of having been built on the JVM, is almost a third more efficient than Ruby. That's amazing, my friends. That's amazing. The JVM is boss sauce software. It does amazing things. And then we have this. We have this, 75. Just round up. I'm going to call that 76. I don't know what 76 divided by 2 is. I'm not great with math but you know who is great with math? Freaking Python. Okay, so 76 divided by 2 is 38. So think about that. If you wrote a program and that program generated, the electricity generated to run that program in Java resulted in a little bit of carbon being captured in the atmosphere, and that carbon in turn raising the Earth's temperature just enough to kill one tree. The equivalent program in Python would kill 38 trees. That's a forest. That's incredibly inefficient. We need to have a conversation about this. Certainly now that that Python is at the heart of so much of this AI stuff, this is not a good result. This is worse than Bitcoin for our planet. Anyway, that's neither here nor there, friends. All I'm trying to say is Java is amazing. I just want to stress that. That said, I would like to make it a little bit faster, right? More efficient. And one way to do this is to proactively compile our code into operating system and architecture specific native code using an open JDK distribution called GraalVM. So I'm going to go here and I'm going to run Gradle native compile. Okay, I'm going to run that in the background. And the problem here, friends, is that that's just going to take a long time. This GraalVM native image compiler is an extra nicety in the OpenJDK distribution that kind of like just-in-time compilation. It looks at your code paths and it finds the code that it can turn into native code and it turns it, but it struggles with certain places where you have dynamic things like reflection, serialization, JDK proxies, JNI, and resource loading. You need to provide metadata in the form of JSON configuration files to the GraalVM native image compiler, telling it about all these dynamic use cases. And that work is tedious, my friends. It's very tedious. And I don't like it for a couple of reasons. First of all, I just don't like saying the word JSON. It just sounds dumb, right? If you speak French like I do, you would say JSON, which sounds cooler. In Taipei, they have a language called Hokkien, and Hokkien, you can say there's a word JSON. Either way, I think these are better than this. So I'm team JSON, but you can pick yours. It doesn't matter. That's part one. Second of all, there's just a lot of it, right? I don't have time to write all this JSON before we finish our talk. We don't even have enough time to finish the talk, let alone write that. So instead, I'm going to use this the AOT engine in Spring Boot 3, and it'll do the compilation for us. And there, it's finished behind the scenes. It took about 51 seconds, right? That does take a long time, my friends. It takes a very, very long time. And usually I get bored. I finally understand this XKCD cartoon, this fabulous XKCD cartoon. The programmer excuse, the number one programmer excuse for legitimately slacking off. My code's compiling. I get this joke now. Hey, get back to work, compiling. Oh, carry on. I thought this was just the C++ people. And it gets to the point now where I start to hum music, or I hear elevator music. So I even went to Oracle. I said, hey, Oracle, please play elevator music during the native image compilation. And I got some great responses. I said, I already hear elevator music in my head. I'd just like everybody else to hear it too. Andrew Din over on the Red Hat OpenJDK Java team, he says, please, can you make it this elevator music? Linking to the Nintendo 64 GoldenEye video game soundtrack. Somebody added that using beeps in general would be a good idea, like a microwave. That makes sense. And then I got this response. Thanks for your feature request, Josh. The problem with playing music during the compilation process is that it's just fixing the symptoms, and we're still working on the cause, making GraalVM more efficient in terms of time, memory, and CPU consumption. Anyway, he continues. He has prototyped this. Now this, I think, would be great. It's native image compiler -- Josh Long mode. It'll play music for you, and then it'll say music brought to you by Josh Long, and then you'll have something to look at. So I'm sure that'll get merged any day now. Let me see. So, okay. So our program did compile, right? So we go to native compile. Here we go. Here's the binary. This program right here, service, 99 megs. Let's try and run it. Okay, we've got a problem, right? The port is already in use. So let's just stop the existing run. Okay, go back here, try it again. We got another problem. We don't have JDBC connection details. Remember, live in that git clone run lifestyle. So over here, I've got this script called run.sh. And what this is going to do is establish environment variables pointing to the Docker instance that we have in our local machine. And then if it's a Maven build, it'll run that. If it's a Gradle build, it'll run that. And I'm just going to run it. Okay, so it's going to run this exact program that we have right here. There we go. 0.1 seconds, a tenth of a second. There we go. All of our virtual threads. Most important for me, my friends, is not the startup time, though. It's the RAM, which you can measure by looking at the resident set size, which is in kilobytes. So you divide by 1,000, you get 118 megabytes to run this program. My friends, that's a it's a thread with unparalleled scalability, instant startup time, super small RAM footprint. We talk into the freaking singularity. We got everything we wanted there. Nice, concise language. It's an amazing time to be a Java and Spring Boot developer. I hope I've still persuaded you. I'm very happy for your time, and I'm happy to answer questions now. Thank you so much.
That was super on time, on the spot, and thank you. That was an awesome presentation. I saw tons of comments that people liked it, loved it. I learned a ton as well. The thing is, we're out of time for the questions. There have been only a couple of questions, but we need to move on to the next session.
No problem.
All of that being said, though, because you mentioned her at the very beginning, I wanted to bring someone back on the screen just to say hello. So
my friend, there we go.
Hi, Josh.
Hi, Mala, fellow Java campaign legend. What book should I be reading to get up to date on the latest Java 22 stuff? I mean, there's so much good stuff out there right now.
The one that I'm writing, and I'll ping you the name.
Okay. I can't wait.
Lovely
Thank
session.
You, Marco.
Yeah, lovely session. Thank you again, Josh. Thank you for the session. Thank you and bye-bye.
Yes.
I myself will hop off, and Mala will take over, and we'll continue with our next session. Bye.
Cheers. Bye, everybody.